Let's discuss the activity table that appeared in the NHT paper 2023, Exam 1. It was the 8th question. They had given you a list of activities, the duration times, earliest start times, and the latest start times. And the question asked you, in this project, the number of activities that have exactly 2 immediate predecessors is. Now, there are various ways of thinking about this question, but the method I'm going to explain to you is the way I best understood it. So I start by first identifying the critical path from the table, and the way to do that is start from the last activity. Its earliest start time and duration gives you ultimately the minimum completion time. Now, to go backwards, so the idea is there's k over here with 5, a duration of 5. The earliest start time at the end of it was 25, and its earliest start time was 20. So 20 plus 5 gave you 25. Now, in order to find the previous activity, we should find earliest start time, which when added to the duration of that activity gave you 20. So in order to do that, we look for 2 activities which when added, the earliest start time plus the duration gives you 20, and we can clearly see 18 plus 2 gives us 20. And then we go backwards this way, two numbers that add to give you 18, which is 14 plus 4 gives us 18, and 2 activities when added give you 14. Earliest start time of 8 plus activity duration of 6 gives you 14, and then 2 activities that give you 8. Earliest start time plus duration gives you 8, and 2 activities that add to give you 6. So all these activities are the ones that will be on the critical path, because clearly we can see over here that the earliest start time and latest start time are all the same. And what I did was I drew a linear line, as you can see over here, with the activities B, D, F, H, J, and K, which were the activities on the critical path. F, H, J, and K. Now, if we have to add the other edges in, because only after we've drawn an entire network can we answer the question, we need to use the latest start time and the duration and go backwards again. So let's look at the first activity from the bottom of the activity table. The one that we need to add is activity I. Now, the way I think about it is, if the activity I, the latest start time for activity I was 17 and its duration was 3, which means that activity could be completed at the end of 20 weeks, 17 plus 3. So the end of that edge should actually go towards 20. So I can clearly see this edge, this is 20 over here. So this edge goes towards 20. Now, where does it start from? So I'm talking now of activity I, so of duration 3. Now we can see over here the earliest start time for activity I is 14. So look for the box which shows you the earliest start time being 14, and take this edge and join it to that point. So that's I done. Now we go on to G. The latest start time for activity G is 10 weeks. Its duration is 8. So if that activity had taken place starting from 10 weeks, it would have finished at 18 weeks. So look along the linear line, 18 weeks, this is 18 weeks, and start the activity edge going backwards from there. But to what point shall we join that edge? The earliest start time for activity G is given as 8. So we take that edge back to where we see 8 in this box. And then, so that's completed. The next one we look for is activity E. The latest start time is 9. Its duration was 5. So 9 plus 5 is 14. So we go to the box which says 14 as the earliest start time over there, and take the edge from there backwards, and sorry, just a second. And so we are talking about activity E. So 9 plus 5 is 14. So from 14 backwards, and its earliest starting time is 6. So take it back to the where it says 6 as the earliest starting time, and that's activity E of duration 5. Now we have activity C. The latest start time was 5, its duration was 9, so it would have finished at 14 weeks. So here's 14 again, and so take the edge backwards from there, and its earliest start time was 0. So take it all the way back to 0. That's done. A, latest start time 1, its duration 7, so it would have been completed at 8 weeks. So 8 weeks is here, and take the edge backwards from there, and its earliest start time is 0. And that is activity A with a duration of 7. Now if we look at the network that we have got, we can clearly see that activity F has 2 immediate predecessors, A and D. Activity J has 2 immediate predecessors, G and H, and activity K has 2 predecessors, J and I, and that makes 3 activities which have exactly 2 immediate predecessors. Now let's practice another question. Similarly, there's an activity table given here with the same details, duration, earliest start time and latest start time. And the question is the number of activities in this project that have exactly 1 immediate predecessor. So as I told you before, let's start from the back. We have this activity table here. So obviously J is the last activity, and so 14 plus 3, 17 would have been the minimum completion time. So now let's find 2 numbers that add to give you 14, which is 10 plus 4. And now 2 values that add to give you 10, which is 9 and 10. And 2 values that add to give you sorry, 9 and 1 add to give you 10, and then 2 values that add to give you 9, which is 7 and 2, and then 2 values that add to give you 7, which is 0 and 7. Now, some of you may have thought, why not 4 and 3? Simply because if you look at the earliest start time and the latest start time, for 4 and 3 they are not the same. So that's another clue. So if you have two numbers that could add up to a number you're looking for, choose the one whose earliest start time and latest start time are the same. So now let's check whether what we've done is correct, because for this particular activity C, earliest start time, latest start time are the same. For E, they are the same. For F, 9. For I, 10. And for J, 14. Now, just as I said previously in the previous question, you can draw a linear line representing this information. So I identified the activities on the critical path to be C, F, I, and J. And as you can see over here, I have drawn C, E, F, I, and J. And I have shown the earliest start times and the latest start times in these blue boxes. Now let's look at those activities that are not on the critical path that need to be added on to the network to answer this question. So let me start first with activity H. Its latest start time is 8 and its duration time is 6. So if it had started at 8 with a duration time of 6, it would have 8 plus 6 would finish at I think it's days, 14 days. So let's look where we have this box which says 14. And we draw an edge that goes backwards from there. But what is the earliest start time of activity H? It's 7 days. So we take it back to this point where we see the box which says earliest starting time is 7, and that's activity H with a duration of 6. Now let's look at activity G. Latest start time is 11 days with a duration of 3, which implies that it would have finished at the end of 14 days. And so that's 14. So draw another edge taking off from there. And where would it go? Its earliest start time is 9. So take it back to this box which says 9. Okay, and that is activity G3. Now the next activity is activity D. Its latest start time is 6, duration is 4, so it would have been completed at 10 weeks. So I can see 10 weeks here. That's the end of the edge. Take it backwards. And its earliest start time is 3. Now this is where you've got to stop and think, because I can't see a 3 along that line. So along the table, I saw that if 3 was the earliest starting time for D, I looked for another activity that could finish at 3, and I found A. So 0 plus 3 is 3. And so I thought obviously A must be a predecessor for D. And so I took it back and then I checked out A's earliest starting time was 0. And so I took it and I drew A, and with its duration time, and connected D to it. I also checked if what I had drawn was correct, because 17 take away 3 gave me 14, and then 14 take away 4 gave me 10 when I did the backward scan. Now 14 take away 3 along G gives me 11, but if you go backwards from the end of 10, 10 take away 1 is 9, and the smaller number is selected, so that's 9. And then if you go along E, 9 take away 2 is 7, and there's another edge coming to the same point, which is along H, that is 14 take away 6 is 8, and the smaller number chosen is 7. And then we still have B to do. Latest start time is 4, duration was 5, it would have been completed at 9 weeks, so I can see the 9 here, and so take the edge back from there, and the earliest starting time for B is 0, so it connects here. And so if you take off from the end of E, backward scan, 9 take away 2 will give me 7, and so we did that previously, I think, and so we chose 7 being the smaller value. Now if you go along B, 9 take away 5 is 4, and to that same point there are 3 edges coming. 7 take away 7 is 0, and the other edge is coming from along D first, so 10 take away 4 is 6, and 6 take away 3 is 3. With all this information matches up to the table, activity table given to you. So now let's answer this question, how many of these activities have one immediate predecessor? So clearly we can see over here that activity A is a predecessor for D. Activity E has one predecessor, that is C, and activity H also has one predecessor, which is C. So these are the activities with one immediate predecessor. So that's 3, and the answer is 3. Hope this helps you. It would be good if you actually just draw out an activity table and try to draw it yourself by following the instructions I've given you. Thank you.